Good morning, everyone, and welcome back to our continuing series of weekly CPD webinars. This time, all about ground gas protection. Should we care and should we really bother? I am your host, Andy Ferguson, and joining me today to help answer that question is one of our senior PCA trainers and also MD of Neil Savage Training, Mr. Neil Savage. Good morning to you.
Good morning, Andy. How are you?
Not bad, good sir. Not bad. Yourself?
I'm pretty good. Got dry weather in Birmingham this morning, so all good. Yep.
Well, I suppose that is always good. I'm being up in sunny Scotland here at the moment in time, Costa del Sol,
That's it.
always sunny up here.
Excellent.
But guys, if you're one of our regular listeners within our CPD series, a big thank you to you for tuning in with us again. If you are one of our new listeners, well, a big welcome to you. And I do hope you get some real good value learning from today, and also that you enjoy the chat over the course of the webinar in itself. For our regular listeners, I do apologise for what I'm about to say just right now, but for those of you that don't know, we're always keen to hear your engagement, your questions, your chat, and even just for you to say hello and just any kind of thoughts that you've got. Now, to do that, first place I would kind of point you to that if you have a desktop, firstly, depending on your settings, there is a chat functionality which will either be on the left or the right hand side of your screen. There'll be a little text box that you can just basically complete in there. Just basically pop in whatever you want to say question wise and hit enter, and we will be able to see it. If you have a mobile device, very similar as well, all you need to do is just very gently just scroll up and you should see that chat facility in there. Just again, pose your question and fire it over to us and just say good morning to us. Good morning to all, by the way, that's using the facility at this moment in time. There is other ways in which you can also pose your questions to myself and Neil. You can email them directly to myself, just at andy@property-care.org. That's andy@property-care.org. Or alternatively, if you are socially savvy, you can go via our social media channels. Either visit Twitter, LinkedIn, or Facebook. Just use the search functionality, type in Property Care Association, and we should pop up. And if we don't pop up, please do let me know, because I'd be kind of keen to hear. So Neil, we've got a wee bit of time just to kill, just while we're waiting for people to kind of join us, and a big hello to everyone that's there. I always feel like we're like ships passing in the night down at the office. What are you trying to avoid me or something?
Well, I do like my visits up to Scotland, but like you say, there's such a busy training schedule of things going on and being in different places. We never seem to bump into each other. So, no, it's good to catch up, certainly via this channel, and looking forward to delivering this bit of training with you today.
Oh, no, definitely. Thanks for coming on board. I mean, I was actually nosing your LinkedIn profile last night. Actually,
I did see you were looking. I
mean, looking into your history and stuff like that, you really were one of the early adopters in terms of kind of ground gas stuff, I have to say. I mean, especially in terms of kind of training, learning, development, getting people on board standards wise. It's great. It's great to see.
Yeah, well, I'm going to talk about some of that as well, the development that went on. It's but it's fairly new knowledge that's coming around. It's only recent, within the last 30 years, I'd say things have really moved on. Before that, it was a very kind of unknown sector. So compared to my base sector, which is joinery, it's been around since time began. People carving bits of wood. So it's very, very new industry, really.
Yeah, and you've been a world traveller as well. I was actually, when I was looking at your LinkedIn profile, I was like, wow, you've even been a world traveller to Bonnie, Scotland, when I saw the words Blantyre. I didn't realise that was Blantyre in Malawi.
It was, yes. Yeah, right. I worked abroad. I had about 4 or 5 years working abroad, various countries, working on a lot of overseas aid projects, which was quite interesting. Really, different different perspective of working around the world, especially in some of the, more third world environments and developing countries. It was really interesting, so.
Well, folks, here I can see we've had a whole bunch of individuals that have just joined us. A big good morning to you all. We are about to start. A big welcome to the latest in our CPD webinar series, all about ground gas protection. Why should we bother? And joining me is one of our senior trainers, Neil Salvage. Now, for those of you who just joined us and are a wee bit unsure about how you can maybe engage with us and chat and pose any questions, you can use the chat facility, which if you're on your desktop, it will either be on the left or right hand side. If you're on a mobile device, you just need to scroll down there and there should be a box in there. You can also as well email your question just simply to andy@property-care.org. That's andy@property-care.org. Or alternatively, visit our social media channels. We're always listening out for anyone kind of chatting about us. So again, feel free to pose anything that may come up at any time. Now, I can actually see that nicely we have just turned 9 o'clock here. So I suppose it's maybe a good time for me to kind of throw over to Neil and really just start looking at, are we really making a mountain out of a molehill when it comes to ground gas protection? And is it really necessary? And do we really care? So Neil, big questions. Over to yourself, good sir.
Thank you very much, Andy. Well, good morning, everybody. And first of all, well, thanks for bothering. It's great to see everybody. So welcome along. And hopefully I've got plenty of interesting developments to bring to you today in this presentation. So thank you again. So just a quick introduction to myself. I'm just waiting for my slides to move along. Oh, we've not got a slide moving, Andy. So
are you on your PowerPoint?
Let me just click onto that. Yeah, should be on it. There we go.
There
it's moving now. There, sorry.
You're all good, mate. You're all good.
Thank you, Andy. Sorry, first time on a webinar. So, I'm Neil Salvage. I've been involved in construction since I left school. So, a good 30 plus years now, I've been involved with all formats of construction. And I've started out as a carpenter and joiner, developed my skills, went into project management, and more recently, well, I say recently, mid-90s, got more involved in the ground gas sector. And I'm going to bring you some of that experience into this webinar today of what's happened in the past and how things are moving on, and things are changing. And hopefully things are changing for the better. It's just sharing that knowledge. That's what I'm quite passionate about as a trainer. And also I'm one of the NVQ assessors for this sector in ground gas protection. So, that's my introduction. First of all, I always do a bit of housekeeping when I do some training. So I know a lot of people are doing webinars and various training formats at the moment, and it's been quite entertaining. Hopefully I'll get nobody in their underpants walking through, or I've got a 9-year-old child in the kitchen at the moment doing his studies. So hopefully we don't get them wandering in, or our dreaded Amazon delivery guy. But if they do, apologies. But by all means, grab a coffee and sit back and relax and enjoy what I'm hopefully I've got to deliver for you. So, ground gas protection, why bother? Now, this is a common question, and I've heard it since I started in the industry, and I still hear it today. Why are we doing this? What's the point? Oh, we didn't do this on the last job. There's no need for this. And often, there's a lot of planning conditions that go ahead of us before we put any membranes in that require the site to be investigated. The risks are analysed before the design can take place. And often you find the construction team you're dealing with on site, and as me as a technician would meet these people, it's kind of been passed then that they've got to make it fit into the program and they've got to fit into the costs. So we tend to find ourselves meeting QSs, site managers, who are very kind of, oh, what's the problem? They're thinking about the money. They're thinking about the timings. How long is it going to take me? And often, unfortunately, it gets passed on to other trades. I've put here brickies, sorry bricklayers, but we do find that they're putting DPMs in the ground, and it nicely fits into the time frame when they're on site that they can deliver that part of the package. And often it's done with very little diligence about the ground gas element. So they will be looking at it and going, oh, well, we can put that in a pounder meter, not a problem. We just chuck it in as we would DPM. not understanding the full consequences if that DPM that is a gas protection system works or not. So they're quite critical things that I find happen on site, and even to this day, as I say, I'm still answering that question when I meet people on site, and it's a little bit worrying still. So sharing that knowledge, please. There's a lot of information out there. We need to get it to people. So if we look at the very early history, gases, ground gases, well, they're everywhere. When our Earth evolved 4.5 billion years ago, roughly, I wasn't around, but the scientists knew it was from various gases and explosions and all the science. I'm not a scientist, but we are surrounded by gas today. Nitrogen, oxygen, big part of a big component of our atmosphere. And when we're working away, we naturally take these for granted. But these gases also accumulate, and they are generated from within the source of the Earth. So ground gases do develop with certain concentrations in oxygen. You'll find that increased oxygen or decreased oxygen can have an adverse effect on certainly us as a human. We are very reliant on roughly having about 20-21% oxygen in our atmosphere. Without that, we lose our ability to work effectively, or if it increases, we can enrich flammability. We all know producing a fire, it needs oxygen. So that's one hazard that we do encounter. As you can see, carbon dioxide's in there as well. It's generated naturally from the processes in the ground, from anaerobic or composting, digestion of soils, leaf matter, etc. So that's been going on, and it's been going on a long time. We can't stop it. So more recently, the history we knew about, and I often get asked this on site, don't you guys turn up with a canary to check what the air quality is doing? Well, no, but thanks to our forefathers who did go down the mines, because this is where a lot of this early development occurred. They used to take a canary, and they knew when the ground gases reached a certain level and they were harmful, the poor old canary would suffer. How they discovered this, I don't know. It's like who ate the first egg, you know. It's a little bit, but they knew that taking the canary, fortunately that's evolved, and it went on to things like having a Davy lamp to detect those different ground gases. And it's the oxidization of the coal that they were digging out that would generate these various hazardous environments for them. So there'd be methane generation down there. If you speak to any miners, and there was a colleague assessor who was involved in the mining sector who told me some real horror stories of things that had happened with ground gases and explosions. So a lot was learned from our ancestors on this side of things. So that's a little bit of recent history. Some of you might be familiar with the Abisted incident that happened in 1984. It's noted in our industry as kind of one of the earliest significant events. Sadly, 16 people were killed in this incident when a pumping station that was built by the local water authority, it was to divert floodwaters from one village through a valley to the other side. And while they were constructing the tunnel, there was they went through a strata where there was natural gas occurring. It was a coal seam, shale gas that they were drilling through. All working well when there was water. Nobody was down there. It wasn't really an occupied building. It was just a pumping plant facility. But then they took local residents on a tour, and unfortunately they drained the tunnel, and during that, gas had migrated into the void that was left by the water. So during the course of the visit, something ignited the gases that built up in there, and they believe it was a methane explosion. Back in those days, people used to smoke in a lot of unusual places. I've heard one rumor that it was potentially somebody lighting a cigarette. So really not a very nice situation. And it certainly set a mark in our history of ground gas. 2 years later, Losco in Derbyshire was another significant event. Slightly different in this format, that it was migrating ground gas from a neighbouring landfill site that permeated through the strata, got into this property. This is Clark Avenue. And at 6 o'clock in the morning, there was a source of ignition that allowed that ground gas that had accumulated in the property to cause the destruction that you can see on the screen now. This, again, 2 years apart from the earlier Abisted incident. So people really did start picking their ears up here and thinking, we need to look at this. And there was the first investigations were really carried out on this, and there was some good guidance and initial findings from Syria documents that were worked on this following these incidents. So again, fortunately in this incident, only 3 people were injured, not killed, no fatalities in this one, but certainly made people have a look and think. Yeah. So that started our early forms of guidance. The BRE, Building Research Establishment, put their first reports together, and BRE 212, these would be familiar documents to those already working in the industry, but these were the founding documents that came out really that set the scene. The government then also took a lead on this element as well, and approved document C, which sits in our building regulations, was first published in 1991. Again, still in existence today. It's been revised. There's been numerous revisions and amendments. 2012, I believe, was the most recent. This side of the industry is where our site investigation, our planners, all the people at that front end are really looking at this stuff here. But it's very valuable just to know that they exist, because document C, some of you will be familiar with other approved documents, A, B, C, D, E, F, and so on. Ventilation, I think document F is quite a key one that a lot of people work on as well with this sector. Just a little point of fact, it mentions about Japanese knotweed in there, and I know the PCA have a knotweed involvement, but approved document C has got it as a contaminant in the ground. So this is really investigating those contaminants that are in the ground, that you're aware of what you're dealing with before you proceed into your planning phase and progress in the building. A document that I refer to occasionally is the BRE 414 document, 2001. It gives the first kind of comments on using gas-resistant membranes. And you can see in there comment 2.2.2, the gas-resistant membranes are mentioned, and they're used throughout this document. Those that look at it, it's kind of useful. Little bit dated now, to be honest, and it could do with a bit of a tweak and a turn, because a lot of the building methods there, it's kind of using very flat, and hopefully you'll be able to see my cursor. Is the cursor coming up on this, Andy? Can you see there for us? Is that holding up there?
Yes, no, I can see your cursor.
Yeah, good. So when the BRE wrote this initial document, everything is on a very flat plane. Every drawing mentions, it shows the membrane is flat all the time. And some of you that will be familiar with putting gas membranes, you'll often find that there's a step detail or a formation at the perimeter to make up that upstand. So none of the drawings in here really detail that. And the other thing that is mentioned is the slab with a geocomposite drainage blanket. That is a little bit of a worry, because it's a very similar product to those using drainage systems. You know, in our structural waterproofing, it's used on the cavity drainage systems. But if it's incorrectly installed or put in the wrong way round, basically, it's not effective in ventilation for gas protection. And that's a common occurrence that we do see in this sector, where, you know, the membranes or the composite venting layers are not installed correctly. So again, needs a little bit of a tweak and an update, I think, there, but it's still a current, and it's still there. That document is still used to this day. So BRE 414. When I'm dealing with my NVQ learners and doing support with those, remember, I don't train them on how to do it, but we look at the different elements of ground gas protection. One of their requirements is to understand the differences. So I say here, are all the gases the same? Well, no, they're very different. They all move, behave, they're built differently. So looking at the methane, water, well, water a gas? You know, you can find it in different states. You can get it in a vapor, in a solid, and in a liquid state. So when you boil water, it becomes vapor. It's in a gas, yeah? But also understanding where, if it's toxic, if it's an asphyxiant, if it generates an explosive atmosphere. So that one, a lot of my learners will say, surely that should be like a blast and an explosion. Well, that's an explosive, you know, as the explosive product, like a bomb or something. But generating explosive atmospheres is something that's quite serious in this sector, being aware of it. And this is a rather unusual one at the end, which is the VOCs, having awareness of volatile organic compounds. I listened in on James's webinar a couple of weeks ago now, where they were talking about the evolution of damp proofing and the DPCs, and it was mentioned in that with the VOCs, and I will touch on that a little bit later on with some of the membrane products about how effective they are against VOCs. So we also look at the structure. Again, I'm not a scientist, but if you look at the way they're built, the way they're formed, we can see there, the very small one we've put in there is methane, very small molecule. And when often you talk to people that are putting a barrier, gas protection in, they say, well, if it keeps water out, it's going to keep the gas out. Well, no, that's not true, because the structure of a methane molecule is far, far smaller than a molecule of water, and it will get through. They behave very differently. Gases have a different route to get into buildings. They don't work whether you can pressurize them, but normally they will flow in various formats. They're driven by pressure in the atmosphere. They're driven by water in the ground, or a flooding or tidal influence. So all these things have quite a major part to play in how they work or how they affect the building. Yeah. And then we have the uninvited guest at the table, which is always the radon side of things. A lot of people will talk about radon. I've been to some of the most unusual places where you'd expect to find radon. And I'm going to put up a radon map of England here. And I've been working up in Norfolk, and they're putting gas barriers in for obviously other reasons, not looking at the site investigation, and then telling me, oh, we're putting a radon barrier in. Everything becomes a generic radon barrier. Whereas if you speak to people down in Cornwall, the southwest, where you can see the darker tiles here, that indicates that there's higher or more noted concentrations or affected properties with radon there. So the radon map of UK is available for the UK. And Andy, not to leave our friends north of the border out as well, there's one for Scotland as well. So everybody, we can see there the Granite City, Aberdeen there, and we can see radon is very associated with the fractured granites in the ground, and that's permeating through the strata. And often it's very difficult, well, you can't really detect it in borehole sampling, for example, but often it's knowing that it's present in the environment where you're working, and that you will be able to design systems in and incorporate that so that should the radon be there, you can do something about it rather than have to take extreme measures later on when it's too late. Yeah, so just got what we call a conceptual site model here. So looking at this is a requirement under British Standard 8485 when you're designing your systems and looking at systems, that you consider the three elements that we've got there. We've got the source in the blue, pathways in the red, and receptors in the green. So the source, we can see here, we've got waste, and we've got peaty soils here down in the bottom by the stream. Pathways is your geology, and then we have the receptors, which is the actual buildings here. You know, that's all the people. We've got various receptors, people outside, even the vegetation, that's a potential receptor. So hopefully when people are doing the site investigation, your consultants will be looking at some forms of remediation strategies where they might adopt shut-off barriers to try and segregate the contaminants. They might look at soil remediation methods where they dig and dump, or they dig and inject, or they aerate the soils. These are all various methods that are used. Or they might use a capping layer. Now, the capping layer was used at LOSCO, and that was one of the driving mechanisms which came off the back of conceptual site models that caused the ground gases to migrate the way they did, plus the atmospheric pressure was a driving force as well. So the weather outside, there was a particularly low pressure weather event that caused the gases to change the way they traveled. So in that instance, they are remediation strategies that might be used. But often we find is some of them aren't adopted, and they just go straight in with a membrane to the building. And I've seen it on numerous occasions where the membranes have gone in, and you'll find that 2 plots, as we can see here, have got gas membranes, and maybe 20 meters up the road, they've not got membranes. It's quite common where people zone the sites into various risk factors. So that's all something that I see on a regular basis, especially on these big multi-housing developments, big estates being built. Yeah. So, but then we get the situation where old meets new. And in this particular instance, I come across a lot of what we call retrofit buildings where the old property's been there hundreds of years, never been monitored for ground gas. Whether it's got it or not is another thing. But often they were designed in a way and built in a way with good ventilation in the underfloor voids, good air bricks, mainly for the timber floors. But that's a good method of, if there was any contaminants, they get dissolved and then pushed out through the airflow. And you'll find that the homeowner will then want to build their new house or their new extension, like we can see here, this very snazzy looking annex to the property. And suddenly they've got to jump through all the hoops for ground gas protection. They've got to put membranes in. They've got to do this, this, and this. Yet the rest of the house hasn't got anything on it. So this could also change the dynamic by putting a building next to an existing building where you're putting all belt and braces gas protection in, but next door has got nothing. So it could increase the potential hazard to that property. Yeah. Syria are currently writing and working on a document relating to retrofit measures in these scenarios. British Standard 8485 is for new builds, doesn't really cover existing structures, but it also looks at the way that that new builds, some planners will adopt 8485 on a new build on an existing structure. So it's interpretation from the local authority, yeah, how they deal with it and how the designer works with it. Okay. So, Andy, this is where I'm going to ask for your help now, mate. The poll.
No worries. Well, do you want to throw out the question then to everyone?
Well, I'm going to look at some of the installation standards now, and we have an NVQ in existence. There isn't an SVQ for Scotland. Everybody operates under the NVQ. So NVQ or not to NVQ? That is the question. Do you think we should be following the NVQ process for our installers to be qualified? Or do you think it's, no, it doesn't really matter?
Well, folks, just to kind of let you know, we've just kind of thrown out the poll there just for you guys to actually tell us. If you're on a desktop, it should just pop up in front of your screen. If you're on a mobile device, you might just very, very slightly, just where you fill in your chats, it might just kind of pop up there. I'm just going to leave it just for about another 10, 15 seconds or so, because we do know that sometimes there's a bit of a lag in terms of response. Neil, I know you can't see the results at this moment in time. You can probably guess it, but there is one huge clear winner coming through. I don't want to say what that is because then it might kind of taint the results. I'm just going to give it another 5-6 seconds, guys. So if you're going to do it, now is the time to do it and throw in the results. So maybe 5, 4, 3, 2, 1, and there we go, just ending the poll. That one clear winner, Neil, basically the winner is yes with 83% of the vote, no with 6%, and 10% saying that they're undecided. Guys, also just to kind of let you know, I've accidentally skipped the bit to actually push the poll so you can actually see the results yourself. So you're just going to have to take my word for it.
Fair enough.
Yes, we're 83%. Many thanks, folks, for engaging in that.
Okay, brilliant. Thanks, Andy. Yeah. So, well, let's again look at the early stage of installation of gas membranes, and kind of this is where I started out. And it back in the mid-90s, it was particularly, a guy in a white van, trade background of some description, and would often offer to put the gas membranes in. It was unregulated back then, so anybody that put it in, and there was various standards. We know that there was some very good and some very poor. So hopefully over the next couple of slides, we'll look at some of them various standards that existed. Yeah. So those that have been on presentations with me would have seen this this picture before. Looks like we've got some self-adhesive here catapulted on from about 20 miles away. Working to a standard is critical in this industry. You know, like doing it, if I said to that technician that had done that, can you go and repeat that again and again and again? They'd never be able to do it. So having a standard method of work is quite a key thing. Also, when you give the product, and this, I'm not going to name any occupations here, but this was obviously given to somebody, a roll of material, a roll of self-adhesive tape, or a variant, it looks like duct tape to me, but that was the effort, and that is a genuine picture. That was taken by a verifier looking at a job, and there was expected to sign that off. So the technician had no knowledge of what was required, what the expectations were. So having that in advance is a real leap forward. Yeah. So in the development of our NVQ process, a little history of it, in 2008, 2009 it was developed, and we launched the NVQ in 2010. So a couple of years with the industry putting it together. And if you've got insomnia one night, please visit the National Occupational Standards website, where you can view VR 612 and 613, and you will see the standards required. Those in the waterproofing sector would have been familiar with VR 762, 492, and 491. Very, very similar to the gas protection in their scope. So they're the learning outcomes that we expect the learners to be able to achieve on a consistent basis to prove their competencies. And ultimately, at the end of the day, you're going to get a nice certificate for doing that. Yeah. So, but that also evolved into the good old CSCS cards being evolved to demonstrate them competencies. So here we can see that the green kind of general construction site operative card is commonly used. And do site managers really check these out? No. I think they just want to tick the box, so they've got something in their health and safety folder to see that you've done a health and safety and an environment test. That's it. Competencies to your specific trade. I hear of more coming through now where people are denied access to site because they don't have a blue card. So demonstrating your skilled worker, which is your NVQ2, is quite, you know, it's becoming more prominent now. People are asking for that NVQ level 2 qualification. You can see a copy of it. And one good thing that we're seeing as well is the NVQ3, which isn't gas membrane installation, but it's supervisory, because some people are reading the Syria guidance where it says NVQ2 for gas membranes is a supervisory role. Well, no, it's not. NVQ2 is not a supervisory role. NVQ3 is a supervisory role. So we're looking at that, and people are stepping up to the plate now to do their level 3 as well in supervising that particular works. So, which is all good. And again, the chip and pin, the chip system on the card, how many cards have you had read in your history? That blue card you're looking at there has been read twice in its entire lifetime. Not very good. So people ring me up and say, Neil, I want to do the NVQ. How long does the course take? Well, first of all, the NVQ is not a course. And I put up this picture here of a young lad, bit of a boy racer by the looks of it, with his Ford ST, whatever it is, with the learner plates. To do the NVQ2, you are actually doing your driving test. You're not doing your lessons. So what we would always advise is seek good training. Look, manufacturers, specialists out there that do welding training, various aspects of it. There's national training standards that are put together by CITB in this sector as well, to look at those, to consider that, because that is going to set you up so that when you do go for your driving test, the assessor isn't going to keep throwing things back at you and saying, well, you know, you need to go back and revise and consider this again. And I'm very active in that. So hopefully that will, you know, there's support out there. So using it before going into this. I actually had a screeder ring me up yesterday, tell me he was on a job. He needs it validated. He needs his NVQs by Friday. Ain't going to happen. Sorry. One disappointed person there. Yeah. But in the improved standards, we do see, you know, the use of tapes being used. Nothing wrong with it. It's more than adequate in the right environments, understanding which environments you can use it. Using the right tools and equipment. Again, we can see the beloved good old heat gun there. Having the technicians understand how to use it, how to set it up, how to maintain it, how to store it. Because I do meet technicians that might have these, but they're absolutely battered to death and the elements are falling apart. They don't push out any heat, yet they're still trying to weld with them. So these are learning criteria that we expect as assessors, that they should be able to demonstrate that and talk us through it and give us a good insight into their operational methods. And we also look at the more kind of industrial welding processes, so using machine welding as well. It's quite a key part of, you know, giving somebody a massive warehouse of 10,000 square meters of installation to do. To sit on their hands and knees with a hand welder is going to be quite time consuming and also not very good for the health and safety, health and well-being of that technician. But understanding, again, welding methods that are out there and can be applied, it's one of the performance criteria we expect. And again, some of the VOC environments, welding is the only recognized method of dealing with that, where tapes are kind of still in dispute whether they are acceptable or not. So again, speaking to your manufacturers on that side of things is quite a key element, and they will guide you of what products they can do. So again, technicians, it's nice to get together with them, talk through working with drawings, working to a detail. They must understand that, yeah. And also understanding all the technicalities of different things they're going to encounter. For example, here we've got some steel stanchions with a base plate, a few pipe ducts, and we've got pipe entries and a acoustic robust detail. So sometimes I mention this in my pre-applications to learners. Have you ever done, you know, acoustic robust detail? No, never heard of that. Okay. We need to find out what these details are, because when you encounter them on site, and we haven't got a vast number of details, but they should be able to look at it, understand, and how they're going to approach doing that detailing here. In this particular example, the technician that did this actually did it in a reverse preformed system out of the hole and then located it in. So seeing good working methods is really, you know, it's really good to see how a technician will adapt their skills to overcome that. Yeah. But despite their best attempts, our good old follow-on trade is our kind of worst enemy out there. They give us many problems, and as you can see here, somebody's identified some puncture damage in the membranes. Unfortunately, they've actually done more damage by marking it with a solvent spray marker to the membrane. That's quite detrimental and causing more problems. And to really rub salt in the wounds, when you let your steel fixers come on afterwards and basically steel saw through the ends of their sheets and straight through the membrane as well. It's an ongoing battle, and I'm sure a lot of you are sitting there going, yes, I've seen that, and you know, it's education that has to go on out there. That job cost a lot of time and money to put right in the end. There was nearly 400 linear meters of damage like that, which actually took 3 days to repair and nearly £4,500 in cost, plus a delayed concrete pour. So QSs don't like that, yeah. So and then if you see situations like this, it's game over really. Driving on reinforcing on the membrane, that's really, really, you know, I see pictures come up on LinkedIn of all these snazzy installation jobs, but then I look at it thinking, how are you going to get the concrete over there? You know, and you can see that a concrete wagon's going to be driving straight over a membrane. That whoever validated that has obviously, well, I don't know how they validated it, but no thought went into the sequence, the process, and how to get that membrane safely in and fit for purpose. They'd be best off actually leaving it out. Yeah, it would have saved money anyway. Yeah. So the other thing is, people look at the designs of the gas protection systems, and here we can see this is a traditional bit of containment stroke landfill lining, where they're using very heavy gauge HDPE membranes. So these could be 1.5, 2 mil thick, very rigid, hard to turn membranes. Great in the environment that you can see there, but the minute you try and put them in houses, and I have encountered this where people are trying to lift a 2-ton roll into a house or cut it down into sections and form corners, it's just not achievable. You know, the membranes aren't appropriate. So I've put a little chart there with turning. HDPE membranes are notorious for stress fracturing when you turn them over a certain angling degree. So a lot of the turns that we use in gas protection are 90 degrees. That would basically put a crack all the way through that membrane at that junction. Yeah. And the other one was looking at the VOCs, having appropriate membranes that can survive VOC impact. Predominantly it's the vapors of the VOCs that are the element we face. Yeah, you can get VOCs in a liquid phase as well, but predominantly ground might be detected as having a VOC contaminant in it. Certainly in the retrofit environment with oil spills, it commonly happens where membranes are put in as a last measure to protect the property from any residual vapors there. But also new builds might have a site investigation report that's detected that VOCs are present in the ground. Yeah. So again, Syria wrote some guidance on that, C748, which is the guidance of VOC membranes with VOC vapors. So that is an element to really research and look at if you're going into that environment where your site investigation has identified VOCs, volatile organic compounds in the ground. And like with our damp proof that James mentioned in his previous seminar, could be a consideration there that crosses over into that sector as well. Yeah. So 2014, this was a real game changer when 735 was published. So I have to give credit there to the authors who wrote that guidance, and it's still active today. Very, very popular document. Well, it's a popular document. It works hand in hand with other documents that are out there. So C735 is your verification document, certainly to have a good understanding. And that ultimately closes this circle that was put together with investigate the site, we risk assess the site, design it, install it, and verify it. So the top box here is our verification, should shut the circle. Yeah. So that guidance document from Syria actually changed the tide. In 2014, my queue for NVQ inductions was like this. And I think most airports in UK are like that at the moment as well. But there was nobody waiting. You didn't need to do it. We don't need the NVQ, it doesn't matter. When that guidance landed in 2014, I suddenly had a queue going around the corner. Now, it wasn't quite as severe as that, but there was a lot of people. Suddenly my phone was ringing. I need to get an NVQ. I need, I've been doing this for years. We're good technicians. Excellent. But doing the NVQ, we need to do that process. Yeah. So that was a real changing thing that happened. It forced the hand of our industry. So when we go back to the NVQ question, 83% of you say, yes, we do need the NVQ. 6 say no. Okay, well, that is valid, because the next slide I take you on to is that when Syria wrote 735, the group put together, and I've heard this, I've heard a brilliant term for this, green target zone as the donut of doom, where people make the consideration on the risk. So it's a risk-based approach to the gas regime we can see here, the complexity of the design. So that's back to the turning, the verticals, horizontals, all those little funny details, acoustic robust details, for example. Then we look at the installation workforce, and it clearly states we've got 2 competencies there, non-specialist and skilled. Yeah. So with those, there was a dividing line of skilled and non-skilled. Now, some of the lower risk jobs might actually be very suitable for a low non-skilled workforce if it's a very simple design, low risk site, yeah, but you might have a workforce that have got, their skills will adapt and they will be able to do the work. Whereas you might have a high risk site in the red zone, very complicated design. You don't want to be putting that into the hands of the non-skilled. And again, this falls into place where VOCs are in present with verifiers will call in 100% verification in them environments. You really need to consider if you're not going to be able to pass a verification plan by putting a ground worker on a high risk site with a complex design. It's just not going to happen, and your verifier will call the shots on this. Yeah. So with British Standard 8485, even there was no changes in the recent revision last year, but table 7 still nominates 2 points for a validated membrane. So that sits on that table 7 for you. Yeah. I put the picture up of Gorebridge. I think we all know what happened there. Well, that was the way Gorebridge was. 2014, again, this incident. Carbon dioxide asphyxiated a group of youngsters, caused a problem. I think you can see the property there at the front that's been boarded up. A couple of years later, it's all gone. The local authorities made the decision to demolish the whole site. 64 houses were demolished there. And when we look at it, I've heard numerous stories, people were killed in there. Well, as far as I'm aware, there was no fatalities in that particular instance. People were hospitalized, but no fatalities. But when you look at that circle of the gas protection, the NHS Lothian report clearly identifies that the problems came around in this early investigate and risk assess stage, because no gas protection was designed in here, so therefore there was no installation. And when the houses were built, verification didn't exist. 735 hadn't been written at that point. So these two were kind of off the hook, if we want to say that. But certainly that is now playing out, that people are looking at that element of ground gas protection. So that forces us, going back to the early phases of ground gas protection design, that really leads us, sets the scene of what we've got to achieve on the installation side. So present day history, kind of to wrap up the last few bits now, I always like to look at a few jobs that I've been involved with and worked on. And there's a classic there down in London. Driving past it or going past on the boat, it's always nice to see. Again, Excel, another big project. These have all got major gas protection systems working on them. Some of them more complicated with ventilation and active systems blowing underneath the floors. Excel's got a big subfloor void under there with a car park. So again, working on that, we worked alongside some waterproofing guys on that one. And then you've got the real quirky design buildings. The architect has a vision, making the vision look really good. And then when you look at the complexity of what the ground was, this was in Nottingham, Triumph Road, on the former Raleigh bicycle factory. This is where they used to do the metal processing for all their tubing for the bikes, and the ground had heavy VOC contaminants in there. Plus they built a basement that was the plant room, which went about 3.5, 4 meters underground. So looks great from the pictures, but quite a difficult project to work on. But seeing the end result and seeing it still working, it's really rewarding to see that. And the other one that we're all working at is getting these houses up that the government have got a big target on. You'll find the brownfield first policy makes developers use ground gas protection. I often hear, "Oh, we did it on the last job, we're going to do the same on this job." There has to be a lot of due diligence done on, is the system right? Is it appropriate? Does it need to be done? Why bother? Because that is a big question that's going on in our industry as well. Why do they bother? Is every gas protection system really necessary? Or is it just a cost that's being put in because the developer used it last time, or is being steered to use it again? Yeah. So I've popped that one in there. And then back to our old meets new house. We can resolve the gas protection elements here with the new build, but then often in London particularly, we're getting these iceberg scenarios where they're developing under the buildings as well. So we're finding that the waterproofing ground, structural waterproofing elements are meeting ground gas as well. So British Standard 8102 is meeting British Standard 8485. There's cross elements in there where the two are having to be looked at together. And I've been involved in a couple of those. And likewise, I've been involved with some oil spill situations where petroleum or domestic heating fuels have leaked, got into the water table, or got into the property. They've got to be resolved and dealt with before any further development and occupation of the building to protect the homeowners from any potential hazards. So these are things that are going on. Watch out for the Syria guidance that's being written on that. I think there's some people sitting in today who are involved on that group. So that's going to be about the retrofitting. Where this sits, I haven't seen any drafts of it yet, but I've offered some contributions on it. So hopefully they fall into place. So I'd like to close with a final quote. So Henry Ford: "The only thing worse than training your employees and having them leave is not training them and having them stay." I know we're in a very difficult situation at the moment with the current climate. And I think it's holding firm on, good companies looking after everybody, but also developing and nurturing those skills that you've got within your sectors to, work better, work more efficiently, and, reputations are being built. This industry's moved a long way in 10 years since the NVQs have come around, and it's positive. I don't get so many horror pictures sent to me now, which is nice, but I'm sure they still go on, but they're getting fewer and fewer. So hopefully that gives you an insight into the world of ground gas protection. And, thanks for all listening in today. I've seen that there's been a lot of comments going on, and I will review some of them. But Andy, back to you, mate.
Well, here, thanks for that, Neil. I think we can all agree. Wow, very, very informative, and nice to see that we've moved on from canaries as well from back in the day. And who knew Japanese knotweed was could be actually tied in with ground gas, and it's been considered as what was it, hazardous waste by
yeah, root contamination. Yeah, so it's in document C. Yeah.
And trust you open up the bloody can of worms with CITV.
We all love CITV.
Well, yeah. Well, folks, we are on to kind of question time. If you do have questions, now is the time to certainly get them fired in. We have had a bank of questions that have come in via email and via the chat at the moment. I'm just going to tell you just right now that there is quite a chunk here, so I'm actually going to try and kind of pick them out here. There's no way we're going to be able to answer them all, but yeah, guys, keep feeling free to fire them in. But I think first question is just going with the ones that came off email prior to the event taking place. So this one, first question: Do we take the risks of the effects of radon carcinogenic, so I can't even say the words property. Carcinogenic properties seriously enough in this country? What do you think, Neil?
Well, it's a big issue that Public Health England, and I'm sure in Scotland as well, they're looking at it. The Radon Council is very active in trying to promote awareness and knowledge on this element. If you speak to people down in the southwest, but certainly Cornwall, I've got a friend down there, and that they know more about radon than some of the specialists I deal with. It's just getting that awareness. Do they really want to put that out that everybody's going to start panic? It's how practical are they going to be in delivering that, and trying to tell people in a non-risk area that you're safe, whereas those that are in a risk area, it's a very difficult one. And I think the people in the radon sector especially should do, they are working very actively to get that brought across. Yeah.
All right. Well, next question from David Reynolds. Because ground gas membranes are so easily damaged by the concrete flooring insulation methods, wouldn't it be better for the membranes to be positioned higher up in the floor? What do you think?
Well, again, there's that design element of it, when the designer's doing their lines and their detailing. So, because I did see another question come up about design and detailing. So when the designer or the person that's working with the designer is doing the detail, it's how does it fit into the build process? Is it cost effective? Is it going to reduce potential damage? And again, Table 7 talks about the membrane usage being able to survive the build process, being able to take the stresses of follow-on trades, etc. It's written into Table 7. So it's very difficult. When I set off in this industry quite a while ago, we used to use a 0.8 mil thick membrane. And it was pretty robust, and it's still out there today, but it was very costly. So when more very effective membranes that are a thinner gauge can reduce the cost. Sometimes the cost is the overriding factor. If they can make it cheaper, then all well and good, but it's that protection measure. You need to apply textiles on it, possibly considering where your insulation might sit, under or over, because that's a very effective protection layer as well. How you train your follow-on trades to that. Do you toolbox talk them? I often give a nice toolbox talk to follow-on trades about what it's doing, what the importance is, and why you should put your carpet slippers on when you go on it.
Well, next question comes from Richard. Morning to you, Richard, and welcome back again. Given the importance of no punctures, etc., post-install, what guidance documents do you advise that we pass to clients to warn them of the issues with follow-on trades and associated damage? Ooh, that could be a...
I think as an installation a contractor installing gas membranes, it's the clear thing is to have that verification plan that your client, who you're working for, knows that this product you're putting in has got to be independently verified. So ideally, your client should be appointing that person, and you should all be sitting around a table before you even put the first bit of membrane in, to say, how are we going to deal with this? Can we pick up any problems that are going to cause problems? So 735 a good verifier working to that code of practice and a good installer knowing what the requirements of verification are going to be can be laid out from two parties to the client or the contractor before you start work, and then it's pre-start stuff. But often I hear many verifiers saying they're getting the phone call the day they're ready to pour the concrete, and everything's happened. And the shot that I actually showed you of all them slits in the membrane, that was a prime example. The verifier turned up on the morning of the concrete pour. About 15 lorries on rotation got cancelled that day. That was a very costly mistake. And as you can see, the installers don't do that. That was done by others. Yeah. So 735, I'd say, is your go-to guidance, and work closely, or, make that contact with your verifier so they know also, because they'll want your installation plan as well, your method statements, how you're going to do it. Yeah.
Yeah, and just to kind of follow on from that point, the PCA is actually going to be releasing some best practice guidance on kind of ground gas, which I believe, Neil, you're kind of working on as well, and kind of helping out as well with along with the steering group also.
Yes, yeah, we've been doing some active parts. I can see a few members there today. So yeah, it's ongoing. We're a little bit paused at the moment, but we'll be back on track as soon as we're back to normality as can be.
Yeah, no, we certainly will. Well, following on just from Richard's point, David actually followed on asking, when should the verifier inspect, and should there be any follow-up visits?
Well, again, this is all down to the verification planning. Now, the verifier, I always say, it's not just checking that membrane to find the pinhole that's going to kill everybody. There's elements of gas protection which could involve, first of all, your 3 points of score for your British Standard 8485. So you've got your structural elements, you've got your ventilation, and you've got your membrane. So really, the verifier is looking at the gas protection system. They should be coming in, even looking at the gas mats, like I mentioned earlier. We talked about a geocomposite drainage layer. Many a time I've seen that's been installed the wrong way round. So the verifier should be checking, they should be phasing their visits at key points where they can confirm that the gas protection system is installed correctly and as to specification and design. So early as, I've even known some to go and look at the piling systems, because piling systems might change. You might go from a cast in situ concrete pile, and then suddenly they turn to a vibro, a stone column pile, which in the ground gas world is notoriously hazardous because of the migration that happens in a stone column. So a good verifier has been in, why have you changed the design? I wasn't aware of this. Suddenly there's more of a gas issue with a vibro column than a cast in situ concrete column.
Well, next question, and I do apologise because the number, it's actually come via text message, and the number, I don't seem to have a name associated with it. So whoever's text, big thank you for your text. But question which will appeal to all our waterproofing specialists that are on here. So, can ground gas protection and waterproofing be combined in below ground situations?
Well, this is where the two are coming to meet, isn't it? 8102 has got reference to 8485 and vice versa. So I know a lot of the manufacturers are working on products which work on both fronts. So, they've got water resistance, or that they work in that environment, but they've also got their the 15105, the British Standard 15105 permeability testing to prove them for their ground gas resistance as well. So speaking to those people, the manufacturers of these products, they're very knowledgeable on that front, and they're certainly evolving and adapting their systems to embrace the two, because like you say, you don't want one waterproof membrane sitting there and then the gas membrane, you've trying to combine these two together, and hopefully the two will, there's a lot of transferable skills with the technicians. They understand how to the waterproofing elements in, and bringing the gas protection measures in as well for them is quite a natural progression and evolve situation for them. So again, designers and manufacturers are certainly working on more of that now, and I see more products that are out there that are working effectively. Yeah.
Well, this next question, I think this might be a case of how long is a piece of string, but let's see if you can answer it. I can see your face already, you little...
Yeah, go on.
This comes from Heather Flynn, who says, does possible variation of thickness when applying a liquid on site make any test data stand up against factory manufactured membranes? So I'm assuming this is he's going on about liquid-based membranes.
Well, again, spray applied, liquid applied membranes. The verifiers out there, if they're working to the 735 code of practice, there's test methods that they will use where they're using electro-pulse testing. So they're, echo sounding the actual membranes. When they're putting their verification plans together, they should be they'd be putting sequences of, the frequency of those testing, what sensors are they going to test that membrane at? Because it's notorious that in the corners and turns that the membrane's often a lot thicker than it is on wide open spaces. So really that's a verifier's plan and prerogative, how they're going to deal with that during the course of the construction and liaising their visits with the actual application. Very often what frustrates me is not having the verifier there when the install's going on, and I know it sounds it's all perfect, it's never going to happen, but timing of when the verifier is actually there to observe applications going on is quite key. To watch it being put in is half of the battle, I would say. Yeah.
Okay, well, I've got a couple of questions that are very kind of similar in theme here, so I'm just going to try and kind of round them off into kind of one question here because I'm conscious of time. But this, I believe, comes from Lee, Ben, and also Peter. Neil, is there a difference between ground gas protection design and gas protection detailing, and who should do both activities? Who is best to do it?
Oh, well, doing both. I saw Peter Henderson pop that question up there. So thanks, Peter. Yeah, the design, I always want to think of it. It's the designing a building is, one person. Yeah, if you're designing a very small structure, it might just be one designer. Under CDM regulations, you've got your principal designer, and then you have a design team. So you have specialists dotted around that design hub. And hopefully, people with their specialities will understand substructures, they'll understand ventilation, they'll understand ground gas protection, they'll understand waterproofing. So that really the detailers sit on the peripheral, contributing to the designer and the architects and the engineers who pull all this together to take that design responsibility, because you're not going to get an expert in every element of a structure, especially when you're dealing with substructures like we are here for ground gas. Against somebody putting the roof tiles on the building, it's a very different domain up there. So that they will call in all those individuals. So I think that's the clear line between a designer who takes all that and listens and takes the input from all their detailers on the peripheral, who are specialists.
Okay, well, guys, we'll only get enough time for a couple more questions, but one question that's just kind of popped up, which nicely kind of follows on the theme about just what we're talking about there, about waterproofing and gas installation. But what, my apologies if I pronounce your name here incorrectly, but Majit's just sent in the question along the lines, what is the actual difference between ground gas membranes and damp-proof membranes? I'm actually intrigued myself.
Well, it's the structure of them. I'm sure there'd be many manufacturers maybe listening, sitting in today, but it's the permeability values, what will pass through different membranes. Obviously, I talked about the structure of a water molecule against the structure of, for example, a methane molecule. They're very different. One will pass through a sheet of polythene, polyethylene very differently to what another one will, because they can get through pores or elements of the structure, the process of that plastic. They will be able to pass through it quite effectively. Yeah. So therefore, while you find a lot of foil-based membranes, which are very good at keeping out the methane elements, the very small molecule of methane, can't pass through a solid sheet of aluminium, even though it's very thin, almost like baker foil that's going through the sheet. So that's the differences. They always used to refer to a 1200 gauge as a default membrane, which was, basically a DPM membrane. But now they're under the British standard 15105 testing. Permeability of that membrane must be proven and tested. Yeah, so that gives it its gas resistant values.
Okay. Well, here another question that's just been texted over to us. Another one which I think will appeal to our waterproofing specialists that are listening to us. Why does ground gas work require a verifier while waterproofing contractors are trusted to get it right without this additional hurdle? I suppose maybe flicking it on to reading that question, it's maybe a case of we'll appeal more to ground gas individuals than waterproofing.
Well, the thing is,
the reason here.
Well, waterproofing. I think we know if it fails, you tend to get a puddle or a damp patch or an odor, don't you? It's very quite detectable to the majority of the population. Most homeowners could tell you that they've got damp coming in their house somewhere. Whereas ground gas, because it's odorless, colorless, tasteless, it's a very different element to try and control and know where it's at. So therefore, the checking of it and the consequences of ground gas, you could see them two incidents that happened, and plus Gorebridge in Scotland, are quite catastrophic when they do fail. Whereas waterproofing, it can cause a major structural element, which long-term could compromise the building. But the waterproofing, I don't think anybody's been killed from a waterproofing, damp-proofing situation, whereas ground gas has got the potential, really, if it does go wrong, it's more, it's pretty serious. Yeah.
Okay. Well, I think this will be the last question that I'm going to throw out to you. But folks, I'm just going to say this. I can't promise, but what I will do is I'll pass over any of the questions over to Neil. And Neil, if you can maybe endeavour to kind of get back to anyone that we've not been able to get back to. But this last question, I've actually noticed it picked up by 3 individuals as well. Now, this might be, again, a needle in a haystack because it is associated round about insurances. But it's along the lines of, is there a defects insurance guarantee system offered by insurers? But on top of that as well, do we actually need a guarantee for ground gas protection? Now, I will throw it out there. I do know our CEO, Steve, is listening in. So, Steve, feel free to take on any kind of thoughts you've got. But, Neil, I appreciate you're a trainer. But from your perspective, what's your thoughts?
Well, warranties and guarantees, it was one element that we were looking at in the steering group of the design training that's coming about. And it's played out. You get various manufacturers offering, obviously, product guarantees that their product will last 20, 30, 40 years, etc. You've always got the point of installation standards. Okay, you're relying on a verifier to sign that work off that it's been well installed. So really, is the verifier a guarantee tick box? We have a lot of organisations there like NHBC sit on the sidelines, especially with the new builds, because they're offering their 10-year guarantee. They're very influential in writing their guidance. They contribute to a lot of ground gas guidance as well. So codes of practice and guidance they're putting forward have to be met as part of the build process. Again, I would say that's more, I tend to not get too involved in the warranty sides of it, because I always remember when I started out, if somebody wanted to prove that a ground gas membrane had failed, either they detect it through testing in the building, saying, look, we're still tracing it, or if they want to dig the floor up and find out where these faults are in it, the chances are they're going to do more damage trying to detect the fault than actually what the fault is itself. So the warranties is a very, very awkward one to deal with. And as you say, amongst the PCA and Steve, I know there's considerations that are there, so maybe it's something that needs to be evolved more on that side of things.
Yeah, no, we agree. And guys, we don't pretend to have all the answers. If you have an opinion, certainly feel free to kind of share it. But just to kind of bring this to a close, if you are looking for any kind of additional information, along with kind of posing any questions to Neil and myself, you can visit our professional section within our website, and we do have a host of professional and technical documents that it's not just associated with ground gas, but associated with all the kind of fields that we actually cover itself. Just to also make you aware, we are going to be going live and launching our ground gas group in May at some point. Don't exactly have a date in, but it will be roughly about May. But we also are, that if you are interested, now accepting applications for membership within the ground gas section of the PCA. So if you want to get that badge of honour, certainly feel free to reach out to us and contact us. And the person that contacted, certainly Sue, so just contact us on 01480 400 000. In addition to that as well, we are actually going to be launching our new 2-day training course, which I know, Neil, you are quite heavily involved in as well. I think you're actually heading up and doing it as well. Correct me if I'm wrong there.
Yeah, I'm in there. Yep, working on it as we speak.
There is going to be details of that coming. We're just at the final stages of kind of finishing and prepping that off. If that is of interest to you, it's a 2-day course. Please do reach out to Jade. And again, just go onto our website, visit the contact us section or call 01480 400 000. And of course, if you want to kind of share out or pass out this webinar to any of your colleagues or friends or anyone of interest, we will have this available to kind of share out just for everyone early next week. Just very quickly, our CPD series is continuing over the next 2 weeks. Next week, we have the first of our Dampness Within Buildings webinars, which is being presented by our very own Steve Hodgson. Registration for that will be live very, very shortly, a wee bit later today. But we also, as well, want to appeal to all the waterproofing specialists. Waterproofing warranty provider standards, which is being driven by Michael Well on the 14th. All details on that on the web link property-care.org/webinars. Lastly, but not least, I just want to say, firstly, a big thank you to yourself, Neil. It's great presentation. It's been great fun working with you as well. The last
Thanks.
couple of days, I think we've had a wee bit of a laugh kind of post everything together. And a big thank you, as always, to our audience for tuning in and listening. Really appreciate it. And we look forward to hopefully catching you on the next of our CPD series. So goodbye, everyone, and have a wonderful day.
Thanks, everyone. Bye now.